so this problem has a grocery store. I hope you're all hungry. Grocery store is opened and has 50 pounds of bananas currently on a display table. But then the customers start removing these bananas, right? They're taking these bananas away. And how fast are they taking away the bananas? Well, the bananas are being taken away at this rate of f of t. F of t is measured in pounds per hour, and t is the number of hours after the store has been opened. Then once the store had already been open for 3 hours, the employees start to replenish the bananas, and that's done at this rate. So t is again the number of hours after which the store is opened, and this time g of t is still pounds per hour, but this is the rate at which the bananas are being put back onto the display. So as with any calculator active problem, immediately when I start these off, I'm going to go and program into my calculator as y1 and y2 the two functions that are provided, so I can call upon them much more easily. So 0.8x, and then I have the sign, and that's going to be of the fraction x cubed over 100 on 0 to 12, and then the second function is 3 plus 2.4, and that has a log of x squared plus 2x, and that's on the interval from 3 to 12, so I'll go over here and control my window to go from 0 to 12, so I'm covering both of them. And then I will do a zoom fit, a zoom option 0, so hopefully I get a good picture out of this. Let's go see. So that blue curve is the first function. That's going to be the one with some sign going on and there's some trig in order to be able to see how fast the customers are taking the bananas. And then here will be the replenishment of the bananas, which is the logarithm graph, the red that was coming in. Okay, very good. Now I have them in there. I can use that to my advantage. First question is saying, how many pounds of bananas are removed from the display table during the first 2 hours that the store is open? So part A just wants us to add up from 0 to 2 the f of t function, which is the rate at which the bananas are being removed, right? The people are eating the bananas with respect to time. So I want to calculate an integral on the blue curve. Notice I am on the blue curve, the first curve, from 0 on the low end to 2 on the high end. So there we go. It looks like 20.051. 20.051. And we are adding up pounds. Let's see, pounds per hour multiplied by hours. So these are pounds of bananas taken over the first 2 hours. So that is the finishing part to the first problem, pounds of bananas taken. Okay, what's part B asking for? B wants us to find f prime of 7 and explain using the correct units what that means. So we have the f function up here. We need the derivative evaluated at 7. So again, I'll take the calculator, and this time we'll calculate the derivative of the first function, the blue function again, at 7. And the value I'm getting is negative 8.1195, so that'd be negative 8.120. Negative 8.120. Okay, this is the derivative of the rate of change. So this is like an acceleration. So these are going to be pounds of bananas per hour squared. And so to interpret this in the context of the problem, I would say after 7 hours, the rate at which people are taking bananas, right? So we're talking about a rate at which people are taking bananas, but then we're talking about how fast it's changing. So is changing at a rate of negative 8.120 pounds per hour, which is the rate at which the people were at that moment, but this is changing per hour. right? So the rate of change is changing. The rate of change, which is pounds per hour, is changing per hour, and this is how fast that rate of change is changing. So that's my interpretation for part B. Okay, now on to part C. Is the number of pounds of banana on the display increasing or decreasing at time equals 5? Give a reason for the answer. So to see if it's increasing or decreasing, we need to figure out if the stockers are stocking up faster than the consumers are taking them. So let's figure out those separately. Let's do f prime of 5, then I'll do g prime of 5, and we'll interpret those. So f prime of 5 would be calculate the derivative of the blue function at time equals 5. So the rate of consumption, they're getting eaten or getting taken off the display at 1.705. 1.705 pounds per hour is how fast they are getting taken off the display by the consumers. And if I want to calculate the derivative, now I'm going to press down to get to the red function, and I'm going to do that at 5. I can see that that is 0.823. 0.823 pounds per hour. And that's how fast the stockers are putting them on. So the consumers are taking them faster than the stockers are putting them on. And so therefore I would say the pounds of bananas, number of pounds of bananas is decreasing because the customers are taking them faster than the employees are stocking them. All right, so that's the reason why at this particular instant we are definitely having a decrease in the number of bananas, numbers of pounds of bananas, because of the different rates of change. Okay, last part. What is happening at D? How many pounds of bananas are actually on the display table at time equals 8? Okay, so remember with the problem we were told that they had from the beginning 50 pounds of bananas. So at the beginning of the day we had 50 pounds of bananas on that display. Then people started eating them. So actually it's going to be a 50 and a minus. And how fast were they eating them? Well, they were eating them, remember actually buying them, right? Probably not all eating them there. That would be a lot of potassium in one place. But so they're taking them off of the display at this rate, and we want to add up all of those rates of change from 0 to 8, because this is we're wondering about at the time equals 8. But then our stockers come in, the employees, and they start to put more stock on. So on the time interval from 3 to 8, they're actually adding on some additional stocks. That's g of t dt. So that's really all we have to calculate here are these pieces, the amount that was there to begin with minus what the consumers are taking plus what the employees are bringing back out. So what is this going to be equal to? So it's going to be, let's not do it in here this time, let's go 50, and then we'll subtract the integral from 0 to 8 of the y1 function, which I already programmed into the graphing part of the calculator, and then I'll add on the integral from 3 to 8 of the y2 function, which is the restocking that was going on. So if we just let our calculator do that work for us, the answer it ends up giving is 23.347 pounds of bananas. And that's how many pounds of bananas there would be on the display at time equals to 8.